If you've been in the drone industry for a while, or if you've just started with drones, I'm sure that you've come across the concepts of overlap.
How the images overlap.
Which is overlaps.
How much overlap do you really need for drone mapping?
But what exactly is overlap? And in fact, what is vertical overlap? And why does it matter? We'll have a look in this video. Hey everyone, I'm Varun from Hammer Missions, and in this particular video, I want to try and break down what is overlap and why does everyone keep talking about it. Let's start with the very basics of overlap, and then let's try and get to vertical overlap, which is sort of a newer concept, and if you aren't familiar with vertical overlap, I would highly recommend watching till the end of this video. Right, to start with the basics, overlap is essentially the common region between every two drone images that you take in your dataset, which is essentially used to stitch all of the images together into a 2D map or 3D model. Now, why does this overlap matter and why does everyone force you to keep having overlap, have 70% overlap, 80% overlap? I mean, why do you need it in the first place? Well, it all sort of boils down to essentially the fundamentals of photogrammetry. And I know that I shouldn't be explaining one complicated word by using another complicated word. And so to simplify, when we say stitching the 2D images into a 3D model or into a 2D map, what we're really saying is we are trying to find common regions between these photographs so that the software can use a technique called photogrammetry to stitch everything together and to actually calculate the depth required in between different images to actually put together a 3D model. And so the way photogrammetry or the technique works is by actually identifying these sort of common features between images. And the more common features that photogrammetry can identify, the better it is at stitching together a 3D model from a point cloud. And how this process works is something I've covered in another video. So if you're very curious about photogrammetry, I would highly recommend watching that video. But in the meantime, all you need to remember that is that overlap is essentially the shared region between two photographs that is essentially used to stitch everything together. And so typically when you're flying a mapping mission or you're trying to map a horizontal surface, such as a piece of land or a farm or a quarry or something similar, you just have to make sure that every two images that the drone takes on its flight path, each one of those two images, essentially that pair of images, overlap with the image in front of it and the image to the back of it, the image to the left, the image to the right, to form this sort of common shared region that can be used by the software to put together a 2D map or a 3D model. So that's overlap, and that also explains why overlap is important. But we're actually going to move to a different subject here. We're going to move towards vertical overlap. Now, what is vertical overlap? Now, we all know that if you're trying to map a horizontal surface, something like, a piece of land, a farm, a construction site, all you have to think about is overlap in the horizontal direction, which is essentially the overlap as the drone is capturing the ground looking straight down. But this gets a bit more tricky when you're capturing things that are not just horizontal, but also vertical. A prime example of that is if you're doing things like facade inspections, or if you're trying to do the entire building capture in 3D. And one of the most common areas that we see where people essentially have a pitfall in this process is that they think of overlap in a horizontal way and not so much in a vertical way. So if you think about how a drone software is able to reconstruct any of these structures in 3D, it's all to do with overlap. And so if you're trying to do a vertical mapping of a structure, all you have to do is flip your plane of reference, and essentially if you're trying to map a facade, all you need to do is make sure you have good overlap between every two images to the left and the right, to the up and the down, and you will get a good 3D model or a 2D map at the end of it. So overlap is still very much the same, but it's now vertical. Now, this is okay and easy to understand, but this is also one of the areas of highest levels of confusion because Let's say you've done your horizontal mapping and let's say you've done your vertical mapping. And comes a day when you want to map an entire building in 3D. It gets really challenging because you're like, well, for the roof, I'm going to have horizontal overlap. And for the facade, I'm going to have vertical overlap. And so you go out there, you pack your drone, you plan your missions, and you go fly the building. And when you come back, you realize, things are not quite stitching together as you expected them to be. And that's because when you do things like full building 3D models, what you've got to account for is not just the horizontal overlap and the vertical overlap, but the overlap between the horizontal and vertical overlap. And in simple words, what I mean here is if you're trying to capture a building, you're most likely capturing the roof and the facade separately. And that's okay. And so you can have your horizontal overlap for the roof and you can have your vertical overlap for the facade. But what you also need to have is the overlap between the roof and the facade. And the most effective way to do this is to essentially use the gimbal angle of the drone and to point the camera at the structure at an oblique angle so that you're capturing a bit of the roof and a bit of the facade. And if you're really pro at mapping buildings, what you can actually do is you can add a slight gimbal angle to when you capture the roof, let's say a minus 70-degree angle to capturing the roof, and you have a minus 45-degree angle when you're capturing the shared region between the roof and the facade. And finally, you have a 0-degree angle when you're capturing just the facade. And so you're able to bring all of these three different components together to be able to build a full 3D model where you have every single image that overlaps with every other image, and there is no single image which doesn't really align or doesn't really share common regions with other images. And so that's how you're able to actually make sure that you have a data set that completely covers a structure. And once you really understand this concept and internalize it, you can actually use it for anything you're trying to map. And guess what? You don't have to always rely on automation for this. Even if you're capturing data manually, which sometimes is the case given obstructions and site safety, as long as you have overlap between every single image to the left and the right, to the top and the bottom, you're able to actually reconstruct that 3D model in proper dimensions in a proper way without any issues. So how do you actually do this in practice? Well, we're going to show you that in the next video where you're going to use hammer missions to actually plan a roof inspection and a facade inspection for a full 3D building capture. And we'll show you exactly how to plan these overlaps so that you never have a mission where you don't have enough overlap between the overlaps. Hopefully this was interesting. If you did, give us a like. And if you have any questions or comments on how the overlaps actually work, do leave us a comment in the comment section. We'll see you in the next video for hammer missions.